All right. So this is attempt three. I'm going to try and make a procedural piano music patch in Max without Max or my computer exploding. So we'll see how it goes. So first we'll start with turning the audio on. What I've got here is Piano Tech by ModArt, which is a plugin that makes piano sounds essentially. I opened it up. I don't know if it shows up on the video. And then Valhalla Supermassive, which is a plugin for reverb. That's going to a gain output, and then finally to my audio interface. So I have this object called mc.midi player, and if I give it a ramp and then a MIDI note value, and then a velocity as signals, so continuous values coming into MC MIDI player. And just to show you what the ramp wave looks like here. Every time the ramp hits 0, it's starting the note. Every time the ramp hits 1, it ends the note. What makes this really cool is that MC is sort of a subsystem in Max. I guess you could say it's a collection of objects that use special patch chords allowing for many notes. So various polyphony techniques, and also anytime you need to deal with like multiple channels of signals at a time, it can be very useful. So instead of having it play one note at a time, we could have it play 3. So how we will do that is first we need to, actually we'll do it this way. I want to use separate phasers. So every measure, yep. I'm going to subdivide every measure into a certain rhythm, and so now if I put a scope there, you'll see, oops, sorry about that, it's just 8. You'll see we'll get these pulses with gaps, which is exactly what we want. Maybe a little faster though. No, we'll keep it for now. And then we can do this a couple times with slightly different values here to get some more interesting results. In fact, maybe what we'll do is have them be different lengths. So we'll do 876, and that should get us some interesting variations. So to pack them all together, we can use mc.pack, and then there's 3 of them. We delete the old one, put this one in. Let's get these scopes so we can see what each of the pulses are doing at the same time. Finally, we just connect them and start. You'll note that I forgot to change the notes. They're all playing the same note. To generate random notes, one technique I like to use is an object called stash. You give it a size, and it represents memory with a certain number of slots, so in this case 8, that can be read from and written to at signal rate. Um, it's a little bit confusing, but the idea is that every time it receives a pulse from a clock, it will advance the read head of the tape. Then every so many pulses, let's say 8, 7, we will resample the current, oops, these are backwards. We will resample the value coming into the tape. So what this means is we get this slowly evolving random pattern of notes. What's coming out of stash will be in the range of 0 and 1, but we should see a little bit of variation, hopefully. We should see some repeating patterns a little bit. Yep, that sort of peak. We're going to go ahead and clean this up. And then once again, we can use mc.pack to bring these in. Oh, yeah, and then finally, we have to fix this. All of the signals have to be MC signals or blue cables, or it won't work properly. So at chans 3, that means 3 channels. This should be working. Oh, these values are very low. They'll be in the range of -1 to 1. So these need to be scaled. So from -1 to 1, we want it to be from, say, 48 to 72, which 2 octaves of from middle C to the C above, I believe. So obviously there's a few problems here. It's not quantized. They're playing random values, so that's not good. What we can do is we can create a quantizer. One way that I like to create quantizers is to split out the octave from the interval within the octave. So to get the octave out of a MIDI note, we can simply divide by 12 and then truncate. So in the case of 62, we divide it by 12, which will be just over 5, somewhere close to 5.1. Trunc would then drop the 0.1, so it would just be 5. And then at the same time, we can modulo or wrap around remainder the value to get the exact interval within the octave. We then want to divide that by 12 to get it into the range of 0 to 1. So basically, if we're at the beginning of the octave, the value will be 0. If we're at the end of the octave, the value will be 1. At this point, this gives us the opportunity to use stash again in a different way. In this case, we can scan through it. scan through some predefined values. In this case, parts of the minor scale, and these values will be loaded whenever the patch is loaded for the first time. We multiply that by 12 again. No, I'm sorry. We multiply the octave by 12 again. And then add the interval that we get here to that. And then we should get a bunch of nice round MIDI values. Yep, like that. Group this together so that we can manipulate it easier. We're going to pass that in to the first sig there. Some quick cleanup. And then finally, when we enable this, we should get some, well, actually, let's make sure these are all loaded. Now we should get some fairly reasonable notes coming out. Yeah, fairly reasonable. I'm going to go ahead and do some refinements here. So suppose we wanted to step through a chord progression, or at least kind of change the level note. We can use stash again. We'll make this one size 4 because chord progressions are oftentimes size 4. And we will have the intervals change from between -5, which is a fourth down, to a fifth above. And that can be added to each of the intervals before they go into the quantizer. And this needs to be done with a slow clock, so every measure. So some refinements are to spread these notes out a little bit so that they aren't colliding with each other so much. So we could bring one down by an octave, and then one up by a fifth. And that should give us a good distribution. This is pre going into the quantizer. And I'm going to make it easier to change the scale. So in this case, let's do I'm just going to add in some more notes. So that's a start. There's a bunch of other things that can be done. For example, probabilistic gating of the notes, so that way the rhythms aren't quite as predictable. One last thing that we can do though is make the velocity not static. Once again, we can use stash and in this case we will use MC, the MC form of it. Oh, actually, instead let's use the sample and hold. And then we need to pack in the rhythms here. Oh, and then we need to scale. The velocity is not scaled, so from -1 to 1 to MIDI velocity range. So let's say 35 to 55. That's basically that.